Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to prepare for the GRE. We have been solving GRE math problems out of this book here, the official guide to the GRE, the revised journal test. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 262. Problem number 14, the only problem on the page there, problem number 14 on page number 262, and today is our lesson number 176. This problem deals with what is known as a rectangular box. A rectangular box, which is simply a three-dimensional rectangle. Let's draw it first so we can talk about it. In part A, they ask about the surface area, but before we talk about surface area, let's just draw the bloody thing. A rectangular box. See what we can do here. This line does not look parallel to that line, does it? It does. Close enough. So far, so good. So far, so good. Voila. There is a rectangular box. It's not as nicely drawn, obviously, as theirs is. So look at theirs, because theirs is drawn properly. But this will do the job. This we are told is 10. I'm going to just fix this line because it bothers me. This we are told is 10. This line coming down straight we are told is 2. And this we are told is 7. And we are being asked to figure out the distance from A to B. From A to B. Which I just realized is the second part, not part A. In part A, they're talking about surface area. What does surface area mean? Surface area means exactly what it says. Surface area means area on the surface. When you're talking about surface area of anything, think in terms of painting. Think in terms of painting. If you have a box, a rectangular box, a three-dimensional box, and if you want to paint it all over, the question is how much area will you end up painting? That's what it is, area on the surface. Now, if you have trouble with this concept, I'm not going to go into too much detail, I'm just going to calculate it. But if you have trouble with this concept at all, go and watch this video. Just type in my name, Keshwani, and then type in geometry for GRE, geometry for GRE, day 3. Even without my name, you'll probably find it. Just type in geometry for GRE, day 3, and watch that video, which deals with the notion of surface area. So let's do it then. First, let's find the area of the top and the bottom. The top and bottom floors are, for the top and the bottom floor, see this is the top, and that's same as bottom. This is 10 and that is 7. So it looks like this. 7 and 10. That's your floor. That's the bottom. This is from here to here is 10. So from here to here is 10. This part I don't want to put it in there. This is 10. So it's 7 times 10. So that's the top. I'm sorry, I'm about to sneeze. Excuse me. That's the top. The bottom is the same thing. So the top and the bottom floors are 10 times 7, excuse me. Ten times 7 times 2, because there is a top and there is a bottom. 10 times 7 times 2. Then we have the front, the left and the right. The left and the right faces these are called faces. It has 6 faces. When they talk about faces, that's what they mean. So the left and the right. The left is 2 times 10. Same thing with the right side is 2 times 10. 10 times 2 times 2, because there are 2 of them. Let's put this 2. Let's put this 2 somewhere else. From here to here is 2. So there is no place to put it. And finally, we have front and rear. Front and rear faces are, the front face is right here. This is 2 and this is 7. So it's 2 times 7. 2 times 7. That's the front face. And similarly, we have one more face in the back. So it's 2 times 7 times 2. And that's all. That's all there is. So all we have to do is simply do it out. 10 times 7 is 70. 10 times 2 is 20. 2 times 7 is 14. Times 2. Times 2 because we have the front face, the rear face, the left face, the right face, the top face and the bottom face. 70 plus 20 is 90. 90 plus 10 is 100. 104 times 2. 104 times 2, which is 208. That's our surface area. Let's do the next part, which is the distance from A to B, which is the prickly bit. That's the surface area, 208. And obviously I'm going to have to erase everything because I need the room. If you would excuse me just for 1 second, I'm going to fortify myself by having a sip. Alright, part B. In part B, in order to figure out the distance from A to B, we first have to calculate the floor diagonal. The floor is this. Floor is 10 by 7. The floor looks like this. This is 7 and this is 10. This diagonal that we're talking about, the floor diagonal, which is this guy right here, from here to here. That's the floor diagonal. Let's give this point a name. Let's call it C. Now, are you able to see that the triangle ABC is in fact a right angle triangle? This makes a right angle. This is a right angle. And we can figure out the distance from A to B, which is the hypotenuse in the triangle ABC, because we know that this height, which is 2, which is from B to C. B to C is 2. We just have to find out A to C. A to C is the floor diagonal of the floor, which is what this is. This is 10 right here, and that is 7. So let's find out the diagonal of this floor, which is a very simple application of Pythagorean theorem. And the floor diagonal is going to be x squared equals 10 squared plus 7 squared. 10 squared is 100, 7 squared is 49, so x equals square root of 149. That's it. That's your floor diagonal. Now that we have the floor diagonal, let's look at triangle ABC. Let's look at triangle ABC. That was the floor. The floor is 10 by 7. Now, let's look at triangle ABC. And of course the point C, we named this vertex. It's not in the picture. We named it so that we can talk about it. And this is what the triangle looks like. This is your A, this is our B, and this is our C. And this thing is a right angle. Do you understand? We just found out that A to C is square root of 149. That is distance A to C, which is the floor diagonal. Floor diagonal is A to C. From point A to point E is the diagonal of the floor. The floor is this part right here, which we found out is square root of 149. So this we know is square root of 149. B to C we know is 2. B to C is 2. From here to here is 2. We just found out that A to C is square root of 149. So again, we have to apply Pythagorean theorem one more time. Very simple application of Pythagorean theorem, since we used the letter x before to figure out this floor, the diagonal of the floor. We use letter x. Let's call it letter y. Let's denote it by letter y. I didn't mean to say let's call it letter y. Let's denote it by letter y. So y squared equals the square of this guy, square root of 149 squared, plus square of 2. Square root of 149 is just 149, plus 4 squared, which is 2 squared, which is 4, so we get 153, which is y squared. Therefore y is square root of 153. Is 153 divisible by anything? Let's see. Obviously it's not divisible by 2 because it's an odd number. Is it divisible by 3? If you've been watching my video, you know how we figure out if the number is divisible by 3. If the sum of the digits is divisible by 3, excuse me for 1 second. If the sum of the digit is divisible by 3, then the number itself is divisible by 3. Here we have 1 plus 5, which is 6. 6 plus 3 is 9. So 153 is divisible by 3. Let's divide it by 3. 153 divided by 3. How many 3's in a 1? 1 has 0 3's. 1 goes and joins this guy, becomes 15. How many 3's in a 15? 15 has 5 3's. How many 3's in a 3? There is 1 3. So it's 51. And turns out that 51 is also divisible by 3 because it's 5 plus 1 is 6. So let's divide 51 by 3. How many 3's in a 5? 5 has 1 3. The remaining 2 goes and joins this guy, becomes 21. How many 3's in a 21? 21 has 7 3's. So it looks like this quantity is 3 times 3 times 37. I hope I did not make a boo-boo. And of course 3 times 3, which is going to come out, is 1 3, square root of 37. Voila. This is the distance we are looking for. Y equals 3 times the square root of 37. A to B equals, I'm not going to put it in there, A to B equals 3 times the square root of 37. That's all there was. That's it. Now listen. I'm going to make it a little bit interesting. We're done with this problem. It's all over. Before I close this video, I'm going to give you homework. And I want you to work on it on your own. But I'm going to get out of the frame for a second here so that you have unobstructed view in case you want to pause the screen and so forth. I don't want to erase it right away. I'm going to give you homework and I need to erase everything. I need the room. Or perhaps I can do it up here. Here's your homework. For tomorrow. And it's a very straightforward, very simple question. And here's the question. What is the greatest possible straight line, that is, greatest possible straight line distance between any 2 points on a rectangular box that is 8, that is 8 by 9 by 12. And I need the room for the answer choices. Where can I squeeze the answer choices? A, B, C, D, and E. Here are the answer choices. 17, 18, 19, 20, and 21. Voilà. That's your homework. Do not watch tomorrow's video, day number 177, until you have solved this problem and until you have the answer for it. One more time, I'm going to read it to you. Very simple, very straightforward question. Question is, what is the greatest possible straight line distance, between any 2 points on a rectangular box, which is what we've been dealing with, rectangular box. There is, and we're given the dimensions of the box, 8 by 9 by 12. And the answer choices are 17, 18, 19, 20, and 21. Alright? I will see you tomorrow. Have fun. Bye now.